Today I'll be taking you on a journey to show how the mathematical concepts translation, reflection, and rotation are used in the animation industry today. Making an animated film is a masterpiece of art which encompasses several aspects of production. Here are the jobs that make up the pipeline. Some are purely art related, some are only math related, and many of them are a combination of both. We will be going over where math is used. Before we dive in, I will briefly review the entire pipeline to avoid confusion throughout the video. These definitions are the simplest I can make them. Now that we are aware of the filmmaking process, let's dive right in. Math is first used in the art headquarters. Art comes after the script writing and storyboarding. Here, environments, characters, and assets are created. A lot of this work is symmetrical because symmetrical things appear more organized and are more pleasing to the human eye. This means lots of reflection is being used. When designing environments and planning their framing, artists frequently reflect certain portions of the image on the y-axis. The same applies to assets and even character designs, where it is proven that symmetrical faces appear to be better looking than those who are not. So remember, reflection is used mainly to frame scenes and environments, and to sketch character models and assets. Welcome to the modeling station, where the 2D sketches Welcome to the modeling station, where the 2D sketches are transformed into 3D models. Modeling is First, with your base mesh, subdivide the faces to make more faces. This gives you more control points to modify your model. Secondly, using various tools, you translate the vertices to certain coordinates on a 3D grid to get the desired look. Along the way, to make the job easier, you can apply symmetry to any desired axis to speed up the process. So we have learned that for modeling, you translate vertices to modify your model, and secondly, that you use symmetry on any axis to speed up the process. Now let's explore the rigging center. Here, rigs are created for character models. To simplify rigging for you guys to understand, it is the process of creating and applying a skeleton to the character. This skeleton helps the character move its body parts to bring itself to life. Rotation is primarily used in rigging. After creating the skeleton, artists rotate a bone from the specific coordinate to test how it interacts with the mesh. The rigging process has taught us that to rig, you must rotate the joints. Now here is the most mathematical of all, animation. Animation, as you guessed, is bringing characters and assets to life with the help of rigs. Let's dive to the math. Translation is the most used transformation in animating. During a process called motion capture, stunt performers wear brightly contrasted suits with white dots which are detected by a computer as points on a Cartesian plane, translating in certain points over time. These calculations are then applied to character rigs to produce lifelike movements. Next we have NURB paths. These are similar to translation vectors. Points are plotted in the 3D world to create a path which an object will follow. This is one of the many methods of animation. Here we have F-curves. These are graphs with plotted points. You can translate these points to certain locations. F-curves are used to make animation look more realistic rather than robotic. Here's a comparison of a robotic and a realistic ball animation. Lastly, we have rotation of joints. This is similar to the rigging process, but here the points are not tested, instead keyframed to create a movement. Matte plays a major role in animation. Translation. It is used in motion capture, F-curves, and nerve paths, and rotation is used in traditional 3D animating. Here we are inside the texturing department. Texturing is the process of adding color to the gray and boring 3D models. Reflection is used in texture mapping. Images are modified and reflected on many axes on the wireframe of 3D models. These textures are then applied to the model. Nodes are used for everything, but are primarily used in texturing. Editing nodes is nothing but translating boxes of various information to connect to other information. In the texturing process, reflection of patterns and translation of nodes are used. One of the last departments is lighting. Virtual lights are used to light up a scene and make everything look good. Lights are positioned by translating them through the 3D world. Lights are moved in certain positions, sometimes forming shapes like triangles. If we dive deeper into the positioning, they're also rotated at specific angles to give certain looks. As you can see, lighting is made up of translating the position of lights and rotating them. Now in the editing department, everything is put together to make a final product. After all the mathematics and artwork, we have created a masterpiece to share with the world. Thanks for watching.